We're always amazed by what AI can do. But how often do we actually ask how it's doing it? In this explainer, we're going to crack open that black box and explore a really fascinating question. How do you teach an AI not just to spit out the right answer, but to actually think the right way to get there?
So picture this. An AI solves some crazy complex math problem. And, yep, it gets the answer 100% correct. Awesome, right? But what if its logic on the inside was totally messed up? What if it made, say, two mistakes that just accidentally canceled each other out? That's the core problem we're digging into today.
This is a huge deal in AI development. I mean, even our most advanced models can have these hallucinations or just make logical errors. When the tasks get really complicated, just one little flawed step can throw the whole thing off track, even if it sometimes, by pure luck, stumbles onto the correct final answer. This is what researchers call the right for the wrong reasons problem, and it's a major hurdle if we want to build AI we can actually rely on.
So, how do you even begin to solve this? Well, researchers have two main playbooks, and honestly, the analogy is perfect. Think back to school, grading a math test. Do you just glance at the final answer and call it a day? Or do you actually review all the work to make sure the student understood how to get there? That's the central question here.
And this slide really breaks down those two philosophies. On one side, you've got what's called outcome supervision. It's fast, it's simple. The AI gives you an answer, you tell it, yep, that's right, or nope, that's wrong. But the huge downside, it's a total black box. You have zero idea what happened inside. Then, on the other side, there's process supervision. Here, the AI has to show every single step of its reasoning, and each of those steps gets feedback. It's kind of like having a personal tutor looking right over the AI's shoulder.
And this visualizes the difference perfectly. Look at the left with outcome supervision. All you know is the final answer is wrong. But where did it go off the rails? Who knows? It's impossible to tell. But now look at the right with process supervision. It's crystal clear. The green highlights show you every single correct logical step, so you can pinpoint the exact moment the reasoning failed. It basically turns that black box into a glass box.
Okay, so that's all great in theory, but which one actually works better when the rubber meets the road? To figure that out, researchers at OpenAI set up a really big, ambitious experiment.
So here was the setup. They took a version of GPT-4 and threw some of the toughest high school competition math problems at it. And the really heavy lifting? That came from human judges who provided 800,000, yeah, you heard that right, 800,000 individual pieces of feedback on the AI's reasoning step by step. They created this massive data set called PRM800K.
And this is what it actually looked like. Real human reviewers went through the AI solutions, line by line, and gave every single step a rating. Positive, negative, or neutral. This is that detailed, nitty-gritty work that really powers process supervision.
So, after all that training, all that data collection, all that analysis, was there a clear winner? Oh yeah. The results were, well, they were decisive.
Let's just look at the data. The key question was, how good was each method at picking the one correct solution out of a whole pool of attempts? As you can see, the data showed a very clear, very consistent winner.
The model trained with process supervision, the one that had its homework checked step by step, it managed to correctly solve a super impressive 78.2% of the test problems.
Meanwhile, the outcome-supervised model, the one that was only graded on its final answer, it came in at 72.4%. Now, that's a nearly 6-point gap. And let me tell you, at this high level of performance, that kind of difference is massive. Process supervision was the clear winner, no contest.
But here's the real kicker. It's not just that the process-trained model won, it also scaled better. The more potential solutions it was allowed to generate and then review, the wider that performance gap became. It was just fundamentally better at identifying a truly correct line of reasoning among a whole bunch of possibilities.
So this wasn't just a win for performance. It turned out to be a huge win for AI safety and alignment too. The method that made the model smarter also happened to make it more transparent, more understandable, and more aligned with how humans actually think.
Now, to get why this is such a big deal, you need to understand something called the alignment tax. For years, there's been this nagging fear in the AI safety world that if you make an AI safer, if you make it more aligned with human values, you inevitably have to pay a price. You'd have to sacrifice some of its raw power, its capability. This trade-off just seemed unavoidable.
But then, this paper dropped an absolute bombshell, and I'm going to read this quote directly from their conclusion because it is just that important. They wrote,
Our results show that process supervision in fact incurs a negative alignment tax.
A negative alignment tax. I mean, just think about what that means. It means there is no trade-off. It's a win-win. The method that makes the AI safer, the one that makes it follow a thought process that humans can actually check and agree with, is the very same method that makes it perform better. You get safety and capability at the same time.
So what's the lasting impact of all this? Well, first, it gives researchers a really powerful reason to build AI that's more transparent, that actually shows its work. Second, it's a direct way to reward a model for thinking in a way that we humans can understand and verify. But maybe most importantly, it shows us a hopeful path forward, one where we don't always have to choose between making AI powerful and making it safe.
And that leaves us with a really fascinating final thought. This study found a win-win for math problems. It proved that the safest, most aligned approach was also the highest performing one. So the big billion-dollar question for the future of AI is this: where else can we find these incredible synergies?
This is for entertainment purposes only.